Alright, today we are going to review what we've learned in chapter 6. There is a review sheet in your packet, and you also have your objective bookmark that can remind you of the big ideas that we've learned. So the first thing you should be able to do for the test is to be able to write a contrapositive, a converse, and an inverse, and then decide if those things are true or false, as well as an original statement being true or false. So, for example, let's say our statement is, if you live in Grand Rapids, then you live in Michigan. We're going to go ahead and say this is true. I know there are other Grand Rapids, but we're going to assume this is true. There are Grand Rapids in other states, but we're going to say our original statement here is true, talking about this Grand Rapids. So if you live in Grand Rapids, then you live in Michigan is our original statement. To write a contrapositive, what do we do?
If you don't live in Michigan, then you don't live in Grand Rapids.
Switch and put the knots in. Okay, a contrapositive makes both changes that can happen. So if you don't live in Michigan, then you don't live in Grand Rapids. True or false? If we're assuming that there's only around Grand Rapids, then this is a true statement.
Will there be a Grand Rapids one on the test?
They will be either definitely true or false with no debate. If your original statement is true, your contrapositive will be true. If your original statement is false, your contrapositive will be false. They are going to be the same no matter what. I would still suggest reading through and considering both of them because sometimes it's easier to understand one of them than the other one. So if you read through the statement and decide what it is, and then read through the contrapositive and decide what it is, and you're getting a different answer, then you know that you might need to put a little bit more thought into this. So I wouldn't just blindly answer the second one and say they have to be the same, but knowing that they have to be the same can help you kind of hammer out what it's going to be. To write a converse, what do we do? Just flip it. So we take the original statement and just say it backwards. So if you live in Michigan, then you live in Grand Rapids. True or false? False. There are a lot of places to live in Michigan that are not Grand Rapids.
Freaking move.
No.
An inverse. Focus. What do I do for an inverse?
If you don't live in Grand Rapids, then you don't live in Michigan.
For an inverse, we leave the original order, but put the knots in both parts. True or false? False. The converse and the inverse will match. Okay. Again, I wouldn't just blindly answer the second one, but think about them both and know that they should end up matching. You will have two pairs, statement and contrapositive match, converse and inverse match. They might all four match, but you will at least have two pairs. Okay. Questions on converse, inverse, contrapositive? You should be able to draw a conclusion or decide if one cannot be made based on a conditional statement. We used Venn diagrams to illustrate this. You do not have to use Venn diagrams, but you could. Let's say our statement is, if it is not snowing, then I am happy.
You must be not happy right now.
We're in these problems always assuming an original statement is true. Okay, that's a given. This is our given information, our given statement. You don't have to illustrate with a Venn diagram, but for those of you who are visual people, it might be helpful. The if is your inner circle. So my inner circle is not snowing. My outer circle is the then. Okay, if is the inner, outer is the then. Then we want to try to draw conclusions or say that we can't draw a conclusion based on other information. So if I say it is snowing, can I draw a conclusion or not?
Not happy.
You can put it on the edge of happy, but that would be no.
No, you can't, because
No.
it doesn't say.
I give it happy when it's snowing too.
Yeah. You
Okay,
could put it
so-
on the edge of happy.
Snowing means that it's not in the little circle, because the little circle is not snowing. So it's not in the little circle. Could it still be in the big circle?
Yeah.
Yes.
Could it be out of the big circle?
Yes.
Yes. So this has no conclusion.
If you were to put that, it'd be on the outer circle.
It'd be on the edge of the outer circle.
So it can
Yep.
be in the big circle and still not be in the little circle.
Yes.
So can I draw it in the normal way or no?
I want you to still write with words whether we're drawing a conclusion or not and not just place your point. But if we were to place our point, the point would be here.
Can I draw it like the normal Venn diagrams are, like side by side? Or
No.
Okay.
Because we need the not snowing to be completely contained within the happy. I'm happy. It didn't really sound like it. I'm happy. That sounds better. Okay. Where would that go? Can I draw a conclusion or not?
No.
No.
It's in the happy circle.
No conclusion.
No conclusion though, because I don't know where it is in the happy circle. Is it in the happy because it's not snowing, or am I just happy? Okay. So no conclusion there. It's within the big circle, but I don't know if it's in the little circle or not.
So if it's gonna be like on the other sides of between the two, it's not gonna have a conclusion.
Right.
Happy.
It is not snowing. I'm happy. Yay. Okay. And
Is that what?
I am not happy.
No conclusion.
And it's snow.
It could be
You
snow.
could be not
Why
happy.
is I am happy?
I am not happy would be located where in our Venn diagram?
Outside.
Outside of everything. Not happy is outside of the happy circle, which means I am nowhere near that not snowing circle. So it's not snowing, which means
No.
it's snowing.
So why did you say you're happy? Why isn't it not snowing? You can do it the other way as well.
You could
This
be-
is based on a converse, inverse, and contrapositive. All of these are based on a converse, inverse, and contrapositive. So the third one down, it is not snowing, exactly matches the if, so the then should follow from that. This last one, I am not happy, would be the beginning of the contrapositive statement. If I am not happy, then
Not snowing.
it is snowing. The opposite of the if is a contrapositive, and a contrapositive should be true if the statement is true. The other two are the inverse first and then the converse, and we don't know if an inverse or a converse would be true or false.
But you could be not happy and it's snow. And it's
If I am not happy, I am not in that happy circle, which means I am nowhere near the not snowing circle, so it's not snowing, which means it has to be snowing. Okay? Not, I know, English is a great thing, right? But if that blue dot is outside of the happy circle, there's no possible way it could be in the not snowing circle.
Huh.
So it's not snowing. So it is snowing.
She can't be not happy.
Spanish actually
It's kind of
requires double negative.
No.
So that means she's always happy.
Spanish
She's
actually
never happy.
requires a double negative, which I think is fun.
I am happy.
And I keep it straight between English and Spanish.
It's a bad example.
You can think about your converse, inverse, and contrapositive if that helps you out as well. And you know the converse statement will be a true statement,
Can you
and
do another one of these?
did I say converse? The contrapositive statement will be a true statement, and the converse and inverse statement will be inconclusive. Okay?
We do know.
But we're going to illustrate this with a Venn diagram, an if-then diagram. Ifs go on the inside, so that'd be 18. Thens go on the outside, so that would be vote. Okay, if goes on the inside, then goes on the outside. So then, given some statements, we want to decide if we can draw a conclusion or not. If you cannot vote, can you draw a conclusion about that?
You're not 18 years old.
You're not 18 years
Oh,
old.
you could be over 18 and still not be able to vote.
Yeah.
Because you could be like in jail or something.
Okay, yes. So given the law, there are some other things that could come into effect. But given our statement, then this is the only conclusion that we can draw given our statement. Yes, given the law, there are some other things that would make you not be allowed to vote, not being a citizen, being a convicted felon. These are all things that would make you not be able to vote. But given our statement, if I am not in the vote circle, I'm nowhere near the 18 circle. Okay, so I'm not 18. You can vote. Okay. If you're 18, you're in the 18 circle, which means you are also in the vote circle. If you can vote.
No.
vote, you're
You could be like 50 something.
So no conclusion, but you put it on.
No.
You can vote.
Or you could be voting for class.
If you can vote, you're in the vote circle, but you don't know if you're in the 18 circle or not. So, no conclusion. If you are not 18,
No conclusion.
no conclusion. If you're not 18, you're not in the 18 circle, but you might still be in the vote circle, you might be outside of everything. If you struggle with the Venn diagrams, the suggestion would be to take your original statement and write out the converse, inverse, and contrapositive. The contrapositive will be true. The converse and inverse will be inconclusive. So you can just write out your 4 statements
Like the
And then-
converse and inverse won't be true.
will be inconclusive.
No.
So that'll be the no
All the time?
conclusion for this type of question, yes.
And the contrapositive will be true.
And the contrapositive will be true.
Just like this one.
Because we assume the original statement is true. The next type of problem on the test is to decide, given 3 numbers, if they can make a triangle or not. So given the numbers 1, 2, 4, can I make a triangle?
No.
No. The rule is, when you add up any 2 of them, it must be bigger than the other one. And that does not work here, so those do not make a triangle.
Yes.
Yes, if I add up any 2 of them, it will be bigger than the other one. So I can make a triangle with those.
No.
No, the rule is it must be bigger than the other one. Equal to is not good enough. So if you add up any 2, it must be bigger than the other one. Okay? There's our rule for 3 sides of a triangle. Any 2 added together must be bigger than the other one. You will have problems that ask you to identify the longest side or largest angle in a triangle.
I'm not happy.
A.
So which would be the longest or the biggest angle here?
A.
A, because it's across from the longest side. Okay, biggest angle will be across from biggest side.
It said go.
Go. Effie.
Alright, it would be.
Second one, Effie.
Lowercase d.
Wait,
Yeah, lowercase d.
Okay, that one is going to be the largest. If this angle is 60, we can figure out how much is left in the triangle for those other two and solve through and find out that x plus 1 must be 61 and x minus 1 must be 59. And this triangle is almost equilateral, equal angular, 60, 60, 60. But the plus 1 is going to be a little bit bigger, minus 1 a little bit smaller. Biggest angle makes biggest side. You need to be able to compare the lengths of sides and measures of angles in two triangles. So that was where we had one triangle. Last night, the lesson was
Painful.
where we have two triangles. Okay, so the first comparison that I want to make is 10 in BC. Is 10 or BC going to be larger? How do we know?
Trusting our eyes.
Don't.
It's going up.
I
so
drew
it's
this
longer.
like out of my mind.
But it's like
not the
going
same.
up, so it's like long.
Because 10 is across from 40.
Because 10 is across from 40 and BC is across from 58 in one triangle. So that first question is actually like the last problems, and we only need to look at one triangle here.
I was going back.
Across from the 40 is a 10, across from the 58 is BC. A bigger angle should make a bigger side, so BC should be bigger. The second comparison I want to make is AB and BD. What do we need to know to compare AB and BD?
What angle BC means?
We need to know the angles across from them. We're comparing two sides, we need to know what the angles across from them are. We don't know that. How can we find that out?
40 plus 58, 180 minus that sum.
Okay, so inside of that blue highlighted triangle, we need to have 180 degrees. So far we have 98, which would mean that we have 82 left over.
Oh, and then
What's next to that?
98.
98, because a straight line has to make 180 as well. So now, what do we have? AB is bigger because 98 is bigger. And we have to make sure we're using a theorem here. Which theorem would we be applying to this?
Angle addition postulate.
As far as being able to draw our inequality conclusion.
Side angle side.
We know a side is the same, we know another side is the same, and we know the angles between them are not the same. So this is side angle side inequality. Okay, so make sure that you're applying a theorem to the problem, side angle side inequality or side side inequality, side inequality. Okay, so that's our next bullet point, is to make sure that you know what those two theorems are. You don't need to know what they say as in like be able to write them out, but you need to be able to, like you did in the homework last night and like in that problem, recognize which one is being applied. So given information, are we applying a side 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 or a side angle side, and then what conclusion could we draw from that?
Are there any definitions on this test?
There are no definitions to write out. The last thing is indirect proofs. We did do some direct proofs in this chapter as well with inequalities. I think section 1 maybe we had some regular proofs, but there will only be indirect proofs on the test. In an indirect proof, there are 4 main parts. How do we start?
The opposite
The opposite.
Assume opposite of what?
of the proof.
Of the proof. Not the given. That is probably one of the biggest mistakes. That is one of the biggest mistakes that students make on this, is assuming the opposite of the given. The given is a fact, and we don't want to touch it. Basically, what we're saying is, okay, so this is what I want to prove. Well, what would happen if that wasn't true? Okay? That's really what we're doing in an indirect proof is saying, well, what if this wasn't true, the thing that we want to prove, and what would happen then? So we assume the opposite of the proof. What happens next? Then, and we do some reasoning. Just like a 2-column proof. So what word is important here? Because. Justify our reasons using the word because. In that 2-column proof part of it, the then part, what is our goal? Where do we want to end up?
The opposite of the
To
given.
contradict the given. So we say but, and we will have a contradiction of the given. And so how do we finish the proof? So, and then whatever the proof is. Yes.
How do you grade these?
About a point per sentence necessary. So the then part is the part that could grow. So if we needed like a couple sentences in the then part, then it would be a point per sentence, essentially.
So if you had like a proof worth 4 points, could we assume that it could be 4 sentences?
Most likely, yeah.
Also, is like, are there multiple ways to grade, or is there only one way?
Sometimes there's multiple ways. It all follows the same structure, but within that then part, just like sometimes there's different ways to do a 2-column proof, there's different ways to get to that contradiction. Sometimes there's faster ways and not as fast ways.
And we have to say 2 things, right? Or can we just
For what?
to contradict?
It could happen in just one sentence in the then part.
Okay, but sometimes it takes.
Sometimes it takes more to get to that contradiction. All right.